ओके जी।
Yes, beta. So today we will start the next chapter, that is chemical kinetics. So chapter is chemical kinetics. तो chemical kinetics जो है first is introduction of chemical kinetics. तो chemical reaction, chemical reactions में जो भी इसकी फिजिबिलिटी है या केमिकल थर्मोडायनेमिक्स है या एक्सटेंट है, ये तीनों फैक्टर पे डिपेंड करती है केमिकल रिएक्शन कि रिएक्शन फिजिबल है कि नहीं, इट कैन टेक्स प्लेस एट द गिवन कंडीशंस और नॉट, व्हाट इज द हीट एब्जॉर्ब्ड और इवॉल्व्ड, है ना, और एक्सटेंट जो है वो डिपेंड करती है केमिकल इक्विलिब्रियम पे, फिजिबिलिटी किस पे डिपेंड करती है, केमिकल थर्मोडायनेमिक्स पे, और एक्सटेंट ऑन केमिकल इक्विलिब्रियम, एंड स्पीड डिपेंड्स ऑन द केमिकल काइनेटिक्स। ठीक है, तो ग्रीक वर्ड काइनेसिस से ये निकला, दैट मींस मूवमेंट, और is a branch of chemistry which deals with the study of chemical rates and their mechanisms. Chemical kinetics जो है it deals with spontaneity, rate, extent or none of these. So it is obviously chemical kinetics जो है that deals with the rate of reaction and its mechanism. Now टाइप्स ऑफ रिएक्शन, तो अगर हम रिएक्शन की टाइप की बात करें तो देयर आर वेरी फास्ट रिएक्शंस, स्लो रिएक्शंस और मॉडरेट रिएक्शंस। तो वेरी फास्ट रिएक्शन की बात करेंगे तो वेरी फास्ट रिएक्शन जैसे क्योंकि माइक्रो सेकेंड्स में इंस्टेंटेनियसली हो जाते हैं, उनको हम बोलते हैं कि दे आर वेरी फास्ट रिएक्शंस। तो जितने भी आयनिक रिएक्शंस हैं वो सारे ही जो हैं दे आर फास्ट रिएक्शन, इवन प्रेसिपिटेशन रिएक्शंस हैं, न्यूट्रलाइजेशन रिएक्शंस हैं, कंबस्टन रिएक्शंस हैं, दे आर ऑल वेरी फास्ट रिएक्शंस। जैसे precipitation of silver chloride occurs by mixing of silver nitrate and sodium chloride. So see, as soon as we add silver nitrate, we get precipitates of white ppt of silver chloride. That is a very fast reaction. Now very slow reaction, very slow reaction which take days or months or even years to complete, जैसे रस्टिंग ऑफ आयरन। आयरन की रस्टिंग जो है अगर आप 10 दिन भी देखते रहोगे, यू विल नॉट नोटिस एनीथिंग हैपनिंग ओवर देयर, बट इट विल टेक्स प्लेस इन द लॉन्ग रन। तो जैसे Fe+O2 6H2O फेरिक हाइड्रोक्साइड बनता है। Moderate reactions, the reactions which are of the intermediate rate, which are neither slow nor fast, but they takes place at a moderate speeds. It's a decomposition of hydrogen peroxide to give H2O and O2. तो ये रिएक्शन जो है दैट इज अ मॉडरेट टाइप रिएक्शन, और ऐसे रिएक्शन को ही हम स्टडी करते हैं। इन्वर्जन ऑफ केन शुगर टू गिव ग्लूकोज एंड फ्रक्टोज, ठीक है, सुक्रोज से ग्लूकोज और फ्रक्टोज मिलता है, तो दैट इज इन्वर्जन ऑफ केन शुगर, और इन्वर्टेज एंजाइम यूज होता है। डिकम्पोजिशन ऑफ नाइट्रोजन पेंटॉक्साइड give NO2 and O2. So these are all moderate reactions. So in chemical kinetics जो है we mainly study moderate speed reaction. ठीक है, क्योंकि very fast reaction they are very difficult to study. Very slow reaction they need not to be studied. Only moderate reactions they are of prime importance. Enthalpies of formation of Al2O3 and D2O3 that is given. Can this data help us to know the rate of oxidation of aluminium and boron? Enthalpies of formation is given. Aluminium to aluminium oxide and boron to boron oxide. One is exothermic, other is endothermic. So which will oxidize fast, aluminium or boron? Yes beta. कौन ऑक्सीडाइज करेगा पहले? और बेटा जी क्योंकि थर्मोडायनेमिक्स है ना, थर्मोडायनेमिक्स डेटा आर नॉट रिलेटेड टू रेट ऑफ रिएक्शन, बिकॉज रेट ऑफ रिएक्शन जो है दैट इज रिलेटेड टू एक्टिवेशन एनर्जी. अभी पढ़ा ना कि केमिकल थर्मोडायनेमिक्स ये बताता है कि रिएक्शन होगा, बट किस रेट से होगा उसके बारे में इट हैज नो इंफॉर्मेशन. ओके, thermodynamic data जो है that is not related to the rate of reaction. You know, first reaction takes place feasibly because enthalpy of formation is negative, so that is more appropriate to take place than the second one. But what is the rate of the reaction? That is not the part of thermodynamic data. Which of the following reactions occur most rapidly at room temperature? यस बेटा, कौन सा रिएक्शन इनमें से रैपिडली होगा? अभी पढ़ा था हमने. डी, ए और बी, सी, डी? बेटा बी, बिकॉज आयनिक रिएक्शंस आर फास्ट, प्रेसिपिटेशन रिएक्शंस आर फास्ट. मेन जो आयनिक रिएक्शंस होते हैं दे आर ऑलवेज फास्ट. ठीक है, स्ट्रॉन्ग एसिड स्ट्रॉन्ग बेस को डालोगे एकदम रिएक्शन होगा. मॉलिक्यूलर रिएक्शंस में क्या होता है, बॉन्ड ब्रेकिंग होती है, बॉन्ड फॉर्मेशन होती है, तो दैट इज डिफिकल्ट टू टेक प्लेस. बट आयनिक रिएक्शन में क्या होता है कि आयंस ही होते हैं, दे कैन कंबाइन इजीली. ओके, speed of the reaction can be moderate, very fast, very slow. It can be moderate, can be very fast, can be very slow. We have just seen. Chemical kinetics deal with those reactions which occur at, yes beta, कौन सी स्पीड से? स्लो, मॉडरेट, फास्ट, ऑल ऑफ दिस. मॉडरेट. अभी बताया कि स्लो reactions need not to be studied, fast speed that is difficult to study. Chemical kinetics जो है it deals with those reactions which are of moderate speed. Now rate of reaction, speed of reaction or velocity of reaction. So rate of reaction, see कितनी फास्ट, कब ये R से P मतलब रिएक्टेंट से प्रोडक्ट बन जाएगा, ये किस पे डिपेंड करता है, कितनी स्पीड से रिएक्शन चल रहा है. तो स्पीड ऑफ एन ऑटोमोबाइल इज एक्सप्रेस्ड एज चेंज इन पोजीशन डिवाइडेड बाय टाइम टेकन. दैट इज फॉर द फिजिकल वर्ल्ड, बट वी आर डीलिंग विद केमिकल. तो केमिकल में क्या होता है, रिएक्टेंट टू प्रोडक्ट. So rate, speed or velocity of reaction is change in concentration over time taken. उसमें क्या था, change in position. इसमें आएगा change in concentration divided by time taken, क्योंकि reactant जैसे जैसे प्रोडक्ट में कन्वर्ट होता जाएगा रिएक्टेंट की कॉन्सेंट्रेशन कम होती जाएगी और प्रोडक्ट की कॉन्सेंट्रेशन बढ़ती जाएगी. तो डिक्रीज इन कॉन्सेंट्रेशन ऑफ रिएक्टेंट ओवर टाइम टेकन और increase in concentration of product over time taken. So rate of reaction may be defined as a change in concentration of any one of the reactants or products per unit time. Reactant to product. So rate of disappearance of reactant. In terms of the rate of disappearance of reactant, it is decrease in concentration of reactant over time taken. So that is the in terms of the rate of disappearance of reactant. Then if we start in between, not from the starting point, we start from R1 reactant to R2 reactant and time at R1 concentration is T1 and R2 it is T2. So change in time, that is T2 minus T1 total time taken, or delta R is R2 minus R1. So delta R should be negative. So see, we'll write the negative sign before it because the rate of reaction is always positive. So if delta R is negative, you know R2 is always less than R1. Initial reactant is more than the final. Now rate of appearance of product. So increase in concentration of product over time taken. So if, let us say at time T1 concentration of product is P1 and at time T2 concentration of the product is P2. So delta T is T2 minus T1, delta P is P2 minus P1. It is delta P over delta T and with plus sign because there is an increase in concentration of product. But in case of reactant, there is a decrease in concentration of reactant, so we put negative sign before it. Now if we represent it graphically, reactant concentration, you know, it will decrease with time exponentially. And for product, you know, it will increase with time exponentially, and after some time it remains constant. So this is the overall concentration. See, concentration of the reactant decreases with time and concentration of product increases with time. And if we talk about the rate of the reaction, with the increase in time, as time increases, the rate of reaction decreases. Rate depends upon the concentration of the reactant. Now units of rate of reaction. You know, it is concentration over time. Concentration is actually in mole per liter, time in second, the mole per liter per second. That is the answer. Okay. So mole per liter per second or mole per liter per minute, or mole per liter can be written as molar, capital M. We can write it as capital M per second. Or mole per liter can be written as per decimeter cube. So mole per decimeter cube per minute. But this is the most commonly used. Now in gaseous reactions, you know, instead of concentration, we use pressure. So partial pressure over time. Partial pressure can be in atmosphere per second. The units of rate of reaction involving gases can be expressed as, yes beta, which one is the right option? Rate of reaction involving gases. Which one is the right option? Yes, beta. So it is obviously it deals with the pressure. It is atmosphere per second. Concentration of reactant increases with time, decreases with time. Both A and B, none of these. So concentration of reactant, it decreases with time. If we have drawn this figure, concentration of reactant versus time, so it will decrease with time. Concentration of product, obviously it will, yes beta, concentration of product increases with time. Okay, so this is the introduction. Now let us do next part. Different ways of expressing the rate of reactions. So there are two types of rate of reaction. One is average rate of reaction, second is instantaneous rate of reaction. So in case of average rate of reaction, let us take an example. Let us say a student takes 20 minutes to reach school by car. So distance between home to school, that is also given 10 kilometers. So what is the average speed of the car? Is 10 distance by time. 10 by 20 means 0.5 kilometers per minute. Called average speed of the car. Average speed that remains constant. But suppose there is a red signal at 8th minute. What would happen? Car will stop. That means at that moment, at that particular time, speed of the car is 0. Is instantaneous rate or speed, that is 0 at that particular minute. So instantaneous rate changes from time to time. So average rate of reaction, rate of a chemical reaction in appreciable interval of time, maybe smallest, but that is appreciable interval of time and is called average rate of reaction. 1 mole of the reactant R produces 1 mole of the product P. If R1 and P1 are the concentration of the reactant and product respectively at time T1, R2 and P2, these are the concentration of the reactant and product respectively at time T2, then average rate of reaction, that is rate of disappearance of R, that is decrease in concentration of the reactant over time taken. So see minus sign before it, that is minus delta R over delta T, minus R2 minus R1 divided by T2 minus T1. Negative sign only indicates decrease in concentration of reactants. And in terms of the rate of appearance of P, so increase in concentration of product over time taken, that is T2 minus T1 over T2 minus T1. Positive sign indicates increase in concentration of products. Concentration of reactants over time taken. Let us say initially concentration is R0. Now with the time, at time T1, it becomes R1. and at time T2 it becomes R2. So this is the graphical representation of concentration of reactant versus time. And this particular interval R average is minus delta R over delta T. In this way we can calculate average rate of reaction. Minus R2 minus R1 over T2 minus T1. R2 R1 you can write it in bracket so that clear that minus sign is before it. Now concentration of the products versus time taken. So initially concentration is P1 at time T1 and P2 at time T2. So it is like this. So average rate of reaction is P2 minus P1 over T2 minus T1. So negative sign to the rate of reaction with respect to concentration of reactant in duration period of time that decrease that represent concentration of reactant decreases, increases, concentration of product increases, concentration of reactant decreases, does not change the rate of reaction. Yes, beta. What it means? Negative sign to the rate of reaction with respect to concentration of reactant concentration of reactant क्या होती है concentration of reactant it decreases rate of reactions की problems पहला for the reaction R to P concentration of a reactant changes from 0.03 molar to 0.02 molar in 25 minutes. Calculate the average rate of reaction using units of time both in minutes and seconds. Yes, beta. देखो R1 is given 0.03, R2 is given 0.02 and time is given 25 minutes. So you know average rate of reaction in terms of concentration is minus delta R over delta T means minus 0.02 molar that is final minus 0.03 molar divided by 25 minutes. So value comes out to be 4 into 10 raised to power minus 4 mole per liter per minute. And in terms of seconds, 25 minutes to 25 into 60 seconds. So it is 6.67 into 10 raised per minus 6 mole per liter per second. Now for a reaction C4H9Cl plus H2O to give C4H9OH plus HCl, concentrations of C4H9Cl butyl chloride at different times given as follows. So this is given. Time is given and concentration of butyl chloride is given. So question is calculate the average rate of reaction during first interval when C4H9Cl changes from 0.1 to 0.0905. Second interval when concentration of butyl chloride changes from 0.0905 to 0.0820. So you know this is the value है ना. So for first interval 0 minus 0.0905 minus 0.1 and divided by 50 over 0 means it is, this is at 0 second and this one is at 50 second. We can check. See, 0 second it is 0.1 and 50 second it is 0.0905. At 100 second it is 0.0820. Okay, so the value comes out to be 1.9 into 10 raised per minus 4 mole per liter per second. Now come to the second, it is 50 second, it is 100 second. So it is 0.0820 minus 0.0905 divided by 100 minus 3. It is 1.7 into 10 raised per minus 4 mole per liter per second. Next, determine the instantaneous rate of reaction at 600 seconds, 250 seconds, and 350 seconds and 450 seconds. See, these are the values. Just see, first it can be determined graphically by drawing a tangent at a time t 600 seconds, or instantaneous at 600 seconds can be calculated by plotting concentration of butyl chloride as a function of time. So a tangent is drawn such that it touches the curve at 600 seconds. See, this is the time interval and these are the concentrations. So at 600 seconds, this is the concentration. And we draw the tangent. So instantaneous rate at 600 seconds minus 0.0165 minus 0.037 over 800 minus 400 means we have to draw the graph. From the graph we can get these values. So it comes out to be 5.12 into 10 raised per minus 5 mole per liter per second. Means tangent is drawn where it touches at 600 seconds when graph is plotted. Similarly, at 250, 350, and 450 seconds. In the reaction 2A to products, this is the question from NCERT. Concentration of A decreases from 0.5 mole per liter to 0.4 mole per liter in 10 minutes. So calculate the rate during this interval. But say the reaction is 2A to products. So average rate of reaction is minus half because of this 2. So it is minus half delta A by delta T. It comes out to be minus half, because if reaction is like this, A moles of A plus B moles of B to give C moles of C and D moles of D, then average rate of reaction is equal to minus 1 upon A delta A by delta T minus 1 upon B delta B over delta T plus 1 upon C delta C over delta T plus 1 upon D delta D over delta T, like this. In this way, minus 1 by 2, 0.4 minus 0.5 over 10, It comes out to be 0.005 mole per liter per minute. Why we write here 1 by 2? Because of 2a. Rate of reaction, average rate of reaction, C. Rate with respect to A minus delta A by delta T. Rate with respect to B plus delta B by delta T. At any instant, rate measured with respect to reactant or equal to rate measured with respect to product. So the rate is minus delta A by delta T at equal to plus delta B by delta T. That's it. Now, if reaction is like this, N1 moles of A plus N2 moles of B to give M1 moles of C and M2 moles of B, the rate expression may be minus 1 by N delta A by delta T minus 1 by N2 delta B by delta T plus 1 by M1 delta C by delta T plus 1 by M2 delta D by delta T. So these are the number of moles. Now for the given equation, find the rate of reaction. PCl5 gas to give PCl3 gas, Cl2 gas. Rate is minus PCl5 concentration over delta T plus PCl3 concentration over delta T plus delta Cl2 over delta T. Now here the question is Hg liquid plus Cl2 gas to HgCl2 solid. Rate is minus delta Hg by delta T minus delta Cl2 by delta T plus delta HgCl2 by delta T. Now come to the next part. Now tell me. Yes, beta. Delta N2O5 over delta T, what we write before it? Hello?
Yes, sir.
What we write before the expression? Delta N2O5 और delta T से आगे कुछ लिखना है कि नहीं आएगा? वो बेटा इन टर्म्स ऑफ डिफरेंशियल इक्वेशन वो जो बोल रहे हो आप वो अलग चीज है. हियर वी राइट minus 1/2 delta N2O5 और delta T. वो अलग जो आप बोल रहे हो ना वो बाद में आएगा. ये डिफरेंशियल रेट ऑफ इक्वेशन है ना. अब बोलो नेक्स्ट के लिए क्या लिखोगे? वेरी गुड. 1/4 delta NO2 by delta T or delta O2 by delta T. So the change is divided by the number of moles. Okay. Rate is, yes beta. In the next case, Anu, tell me what we write. लड़की ना क्या करते हो आप? सिर्फ आपको इतना सा बताना है कि डेल्टा H2 बाई डेल्टा T के आगे कुछ लिखना है कि नहीं लिखना है? बस तो इतना बोलना है आपको और कुछ नहीं. इज माइनस 1/, और ये डेल्टा NH3 बाई डेल्टा T के आगे 1/2. Now instantaneous rate of reaction. So rate of reaction at a specific instant is known as instantaneous rate. Average speed, you know what is that? कितनी डिस्टेंस कवर की कितने टाइम में और एक पर्टिकुलर टाइम पे कितनी स्पीड है, दैट इज कॉल्ड इंस्टेंटेनियस स्पीड. इस केस में लिमिट डेल्टा T टेंड टू 0 delta C by delta T. Change in concentration measured over an infinitesimally small time interval infinitesimal time span, that is called instantaneous rate. In this case, now in case of average we write delta. In case of delta t, delta PCL5 or delta t, that is average. In case of instantaneous, we replace it by d by dt. So it is delta means larger change, right? And small d means infinitely small change. For an instantaneous rate, we write like this. In this case, again, expression is same. Only delta is replaced by d. Rest things remain same. Now, in graphical representation, you know, is the graphical representation of reactant versus time. So this is average. Now, if we draw a tangent, so this is called instantaneous average. And if we have this interval, very small interval, right? In limit delta t tend to 0. So that is called minus dr by dt. So rate is slope of the tangent. Rate of reaction for this particular reaction. Yes, tell me, which one is the right option? Yes, so option A is the right one. Yes, for the reaction, rate of reaction can be expressed as, which one is right? Yes, because in 1 by 2, that comes out to be 2. So this is the right option. Okay, for the reaction 2N2O5 to give 4NO2 plus O2, rate of reaction is, oh, so 1/4 d by dt of NO2. The A option में minus sign is missing, otherwise that is also correct. Minus 1/2 dN2O5 by dt plus 1/4 dNO2 by dt or dO2 by dt. Rate of reaction at a particular instant is called average rate or instantaneous rate or both. Obviously it is instantaneous rate, because at a particular instant that is called instantaneous rate. So instantaneous rate can be found by calculation, by experiment, can't be found, or we can calculate it graphically. So instantaneous rate is tangent of the line, right? That can be represented by graphically. Okay. इतना ही करें, इतना कर लेना आप लोग, नेक्स्ट क्लास में बाकी करते हैं.